In this review, we're going to deal with the lymphatic system and the non-specific host defenses. So first, let's just do a very quick review of the lymphatic system. I know it was covered in 211, but still it's good to just review. Recognize that the lymphatic system is a complex system that consists of organs and cells and fluids, and its primary goal is obviously to help the body defend itself against foreign invasion. So the components, when we refer to the term lymph, that refers to the fluids, the lymphatic fluids. The lymphatic fluids, as you may recall, flows in one direction. It moves through the tissue, interacts with the blood, those kinds of things, and its main goal is to help move along pathogens and the cells that are needed in the responses. There are two types of organs. We refer to the primary lymphoid organ and the secondary. The primary are the ones in which the lymphocytes are made and matured. So that's going to be the thymus and the bone marrow. The thymus is the site for T cell maturation. The bone marrow is the site for B cell maturation. The secondary lymphoid organs are where the actual activity for fighting off a microbe or a pathogen occurs. Those are going to be various types of tissues, from the tonsils, the spleen, gall, and various other lymphoid tissues. So when we talk about the lymphatic system and the immune function, or the immune response, there are two main branches of this. There's what we refer to as the non-specific or innate branch, and then there's the specific or the adaptive branch. Now, their names kind of imply on how they act or when they act. So let's first talk about the innate or the non-specific. The non-specific is the first response that the body has. It's innate because it's what you are born with. It's non-specific because it acts the same regardless of the microbe or the antigen. So it doesn't care if it is the flu virus or if it's a bacterial infection or if it's a parasite. The non-specific innate responses are going to behave the same way. Whereas when you talk about specific responses or adaptive responses, it's just as the name implies. These are going to be specific for the type of antigen or the microbe. They're going to be your body's way of adapting to that particular kind of response. And it's going to be due to memory. So every time you are exposed to that same antigen, that same foreign body, your body's going to start building up greater and greater responses, and it's going to be specific for that type of microbe. We're going to deal with the adaptive or specific in part 2 of Unit 4. So this video is going to basically concentrate on the innate non-specific. And when you look at innate non-specific, there's two lines. There's first line and second line of defense. This is just an overview. We're going to contain all these parts, but I will say before we move on, you should look at them and be able to identify very quickly. For instance, if I say chemical barriers, where do they belong in the immune response? You should be able to tell me, two things about chemical barriers. First, that they're part of the first line of defense, and then you should also be able to recognize that they're part of the non-specific or innate. If I say something about complement, that you should understand it's second line of defense or non-specific. So let's talk just a little bit more about non-specific, or just to refresh what I just said. First of all, it is what you're born with. It's innate. So it is what your basic mechanisms that are going to be the first and second lines of defense. They're going to be very broad spectrum. They're going to react the same way regardless of the type of antigen or foreign body. They're not going to produce immunity or long production or protective immune response. So let's look specifically, as again, this was the first line and second line, so let's look first at the first line of defense. Now, when we're thinking about the body's host mechanisms for fighting off a pathogen or some kind of antigen, let's go back to what we talked about in one of the previous reviews. If it is a bacteria or some kind of pathogen, remember its job is to create an infection, and there were stages or a process to the infection. The first thing that the pathogen had to do to be successful in becoming an infection was it had to gain access. Remember, portal of entry. Then it has to be able to establish itself. It has to be able to fight off the host immune responses, then it has to do tissue damage, and then it has to exit. So think about those 5 steps and how our body has to then fight off against it, So if the first job of the microbe is to get into the body, then the best line of defense for us is we can't get sick if it never enters our body. So our first line of defense is anything that we have that prevents that microbe from entering the body. So first line of defense, if you look at it, what is it? It consists of physical, mechanical barriers, chemical barriers, your normal biota, and genetic barriers. So physical, chemical barriers, what do we mean? Well, those are going to be those literally the physical elements you have in your body that prevent things from getting to the inside. So it's going to be those epithelial type tissues, skin and mucous membranes. Chemical barriers, well, those epithelial tissues also secrete chemicals that help us in that fight against the microbes. So oil glands in the skin. Oil is considered antimicrobial. Makes that so the skin and even salts make it so that microbes can't last on our skin, don't want to be on our skin, and therefore if they're not going to last there long enough, they may not be able to find a way to break through the skin. pH of the stomach. Okay, so again, if it's very high acidity, that is an antimicrobial agent. That acid can kill microbes. Enzymes in the saliva and tears, we call them lysozymes because they can tear down and break down cellular components for those microbes. And again, in the pH scenario, urinary tract has got a high pH, and again, that is antimicrobial. So those are just some examples of the chemical barriers. Another piece of it to consider is that your body already has its own microbes that it's living in peace with, okay? You're living in unison and synergy here. So if you already have microbes there, just having microbes present prevents other microbes from wanting to come in and inhabit an area, okay? Think about it as if a house is already preoccupied with one set of tenants, another set's not going to just come in or not want to, okay? Not without some kind of resistance. So if we already have our own set of microbes there, that in itself is a resistance or makes it so other microbes don't particularly want to come in. And then genetic barriers. Usually if we get diseases as humans, we get them from other humans. So most microbes like to stay within typical species. Doesn't mean that we don't get diseases from others. Yes, you can pick up some diseases from your cats and dogs, etc. However, we don't get a lot of them, okay? It's most microbes that are going to be for feline or for porcine or bovine or canine, they're going to stick within those species. So we do have genetic barriers in that not everything that impacts your pets is going to impact you. So even though our first line of defense is great, it maintains and keeps out 99% or more of the microbes that we come encounter with every day. Some of them get through that first barrier or we would never get sick. Okay, so some of them get through. So what happens as soon as they break through that first line of defense through those barriers, then the second line of defense, its job is, we've been invaded. So we cannot allow that microbe to go in and be able to do its second and third stage of infection. So we don't want it to be able to adhere, and we don't want it to be able to establish itself and start its replication. So in other words, your second line of defense, if you look at what it's going to be chemical and cellular defenses. And what it's trying to do is it's going to try to wall off the pathogen when it enters into your body and keep it localized, okay? Keep it in a small area, and through its chemical and cellular components, it's hoping it's going to be able to defeat it right there. If for some reason it can't defeat it with its second lines of defense, what the second line of defense is doing is holding that pathogen in one small space, allowing the third line of defense or the specific immunity to be activated and come in to help. Now that part again is the third line of defense we're going to get to in part 2 of Unit 4. So let's look at a couple of second line defense mechanisms that are in play to help us with containing an infection should it get through that first line of defense. So one of the main things that our body has to help us in the second line of defense is the process known as inflammation. The inflammatory process is both cellular and chemical in nature. What you need to know are what are the 4 steps, what are the major events that occur in each step, and what chemicals are responsible. So let's think about it that you're in the kitchen, you're cutting up something and you whack and whoops, you cut your finger. Okay? So immediately, what do? You grab paper towels, a towel of some kind, and you grab it and you throw it and you grab a hold of your finger, and what are you doing? Okay, it's throbbing. So let's talk about it. Then you let it go. Notice a few minutes later, the bleeding has stopped. You come back the next day, and now where you got cut, it's probably nice and red and sore, tender, probably got some swelling going on. A few days later, you may even start noticing pus. And then a few days later, you probably start noticing the scab and that it's healing over. Okay, that's an inflammatory response. It's also skin healing. So let's talk about what happens. The first thing that has to happen in the inflammation response is you actually have to do damage, or you have to injure your tissue. All right, that injury in itself is what's going to initiate the inflammation. Why? Because the injured tissue releases something known as bradykinins. Bradykinins start the inflammatory reaction. So in this first step, what's going to happen is, well, when you cut yourself and you start and the bradykinins are released, that's going to then stimulate those nerve endings in the injured area. Why? You might be like, I don't want pain. Why are we doing that? Pain is necessary for the process. First of all, what if the injury was on the bottom of your foot when walking somewhere and you stepped on a nail or something and you didn't know it? It could be hours or a day before you even get it cleaned or attend to it. What if it's an internal? So you have internal tissue damage and then you can't see it. Without pain, pain is an essential part of this process. So it lets us know that we have an issue, okay? The other thing that's going to happen is when the bradykinins are released, we don't want blood, especially if it's a wound to the skin or to the outer, and so that the blood could actually leave the body or leave the area. So the first thing that's going to happen is those blood vessels are going to constrict, and we're going to try to slow blood flow. First, we don't want other things coming in that might be pathogens, and we don't want the pathogens moving out. So we're going to restrict initially the blood flow area. And then what we're going to do is, using chemotaxis or chemical responses, we're going to start then we're going to let the body know, hey, we're injured here, and we're going to start to bring white blood cells to the injured area. Why? Because it's those white blood cells that are going to be the soldiers or the defender and try to get rid of that foreign antigen. The second stage in inflammation is called the vascular changes. And there's two things to the vascular changes. It's not only blood flow change, but it's also fluids, interstitial fluid changes, okay? So the chemicals that are responsible for this are prostaglandins and leukotrienes and histamine, okay? So prostaglandins and leukotrienes, those, once the bleeding has kind of stopped or has been slowed enough, the prostaglandins and leukotrienes are released, and then what that does is it tells the tissue to increase its vascularity. So what that does is it allows it to become more permeable to blood, to interstitial fluids, and that makes it now so that those cells that were being called to the area can easily move out of the blood and into the tissues where the damage probably is. However, as you start pulling cells and you start bringing fluids in, that interstitial fluid, that lymph fluid in, what's going to happen is you're going to start seeing edema or swelling. Now, I keep talking about we're bringing cells in. The two cells in particular at this stage that are going to be coming in are the neutrophils and the macrophages, because those are our phagocytic cells, the main phagocytic cells. They come in, neutrophils first, macrophages second. They come in, they're scouting the area, and they're looking for any of this foreign antigen, for the bacteria, whatever that has entered our body, and their job is to go in and attack that foreign substance, eat it, and destroy it. There's a whole video on its own for the phagocytosis process. So the other cell that's being brought to the area is the mast cells. Mast cells release histamine. Histamine is huge in this process because what it does is it's going to then dilate our capillaries, bringing more blood flow in so that we can start bringing in the pieces to do repair of the damage, etc. Okay, so it's just bringing everything in at this point in time that's causing that redness that you see in inflammation and the heat that's coming in with inflammation. All right. At this point in time now, so you've had swelling and heat and redness and pain, okay? Pus at this point, after, and every one is a little different in time frame. It depends on how severe the inflammatory process is, where it occurs, etc. But pus will start to occur after a couple of days. What that is as the tissues swelling starts to go away and stuff, and as those macrophages and neutrophils have done their job, and as they're killing those bacterial cells, all those dead cells and everything in the area form this pus, okay? And they begin to accumulate, and then that is what the body then clears as the infection goes away. the last part of inflammation is also very important, and it's occurring around the same stages as 3, and it's moving on, but it's the last piece to end it, and that's when the tissue itself has healed and repaired itself. So again, understand the inflammation process. Again, injury causing bradykinins, histamine get released, and so just going through the 4 signs, which is the redness, swelling, heat, and pain. One of the things I referred to in the inflammatory process was another of the cellular components that occurs, and it does occur in unison, and that is phagocytosis. For phagocytosis, you do need to understand that it is a cellular process. It is the neutrophils and the macrophages. The other thing you need to recognize is that macrophages, when they're floating around in the blood, moving around and not active, we call them monocytes. When that tissue damage occurs and it calls the monocytes into the area of damage, when the cells leave the blood and enter the tissue through diapedesis, then they change their activity and they become aggressive and they become macrophages. So understand that it's neutrophils and macrophages. They're the scavengers. They go in, they engulf the foreign particles and get rid of them. So the whole process, there's several steps to it, is in a whole video by itself that you need to watch, and you do need to be familiar with phagocytosis. What is a phagosome? What's a lysosome? What are the PAMs and the PRRs? And how does it know that this is a foreign thing that it needs to engulf versus self? Okay. The other process that I want to discuss in the second line of defense is something known as complement. Complement is a very complex process. So we're not going through it in detail. I just want you to realize that it does take 26 different proteins to come together. And it's a 5-step process, okay? So that starts with the initiation and ends with these proteins forming what's known as a membrane attack complex, or MAC. And notice here, if you will, that these proteins then form, like they go in and they act like, think of about a balloon that if you went in and you jammed pegs in it, okay? And so that it creates almost a pore. Well, what's going to happen to the cells, same thing that's going to happen to the balloon, is it's going to lose its integrity. And so therefore, what complement does is it will then help destroy the foreign objects. Now, so it's used to assist and amplify immune processes. There's several different ways it can be activated, the classical versus the adaptive method. And again, it depends on what the antigen is. So this one kind of works non-specifically, but it also has a little bit of specificity in it. So you'll see it throughout the unit. So that concludes part 1.